In this video, we're going to review factoring techniques. We're going to look at two techniques, the difference of two squares and factoring trinomials using the sum and difference method. You have done both of these. What is factoring? Factoring is a method to find the basic numbers and variables that make up a product. So factor times factor equals a product. Some numbers are prime, meaning they are only divisible by themselves and 1 and are not factorable. Think 1, 2, 3, 5, 7, etc. When factoring trinomials, we always try the GCF method first. We just studied that last time, the GCF method. Okay, this time we're going to, if we have two terms, we're looking at the difference of squares. If we have three terms, we're looking at the sum and product method. We'll look at four terms in a few, 2 weeks. Method number 2, the difference of two squares. So here is the basic formula. If you have a squared minus b squared, then you get a plus b in one set of parentheses and a minus b in another set of parentheses. What is a perfect square? Well, let's think about it. Any term you can take the square root of evenly. In other words, you don't have a decimal, like 25. Well, the square root of 25 is, that's right, 5. Square root of 36 is, yep, 6. Square root of 1 is, that's right, it's 1. Square root of x squared, you have two of them, so you get 1. And the square root of y to the 4th would be y squared. These are perfect squares. So the difference of perfect squares, let's take this one. We have x squared minus 4. The answer is going to look like this. We have two sets of parentheses. We're going to take the square root of each part. So x squared gives us an x, and 4 gives us 2's. And then notice that 1 has a plus and 1 has a minus. And this is because you don't have any middle terms. Okay? Here's another example. This time we have x squared minus 64. We're going to take the square root of each part, and then one gets a plus and one gets a minus, because the square root of 64 is 8, and the square root of x squared is x. All right, let's take a look at example 1, 9x squared minus 16. What are the square roots? That's right, the square roots are 3x and 4. Next, we just have to put them in parentheses, one with a plus and one with a minus. Let's take a look at example 2. X squared minus 16. What are the square roots? That's right, x and 4. And again, we just place them in the parentheses, x plus 4 and x minus 4. All right, we have 36x squared minus 25. What are the square roots? That's right, the square roots are 6x and 5. Again, we just put 6x plus 5 in one parentheses and 6x minus 5 in one parentheses. This should be coming back to you. All right, it's very possible to use more than one factoring method in a problem. So remember, always use your GCF first. So we're going to take a look at this. Notice we have 2b squared x minus 50x. What is our GCF? That's right, our GCF is 2x. When we take the 2x out, notice that we are left with b squared minus 25. Now we can use the difference of two squares. So we get 2x and then b plus 5 and b minus 5. Let's take a look at another one. Here's our equation, 32x cubed minus 2x. Do we have a GCF? What is it? That's right, our GCF is 2x. Notice we get 2x, 16x squared minus 1. Well, 16 and x squared are perfect squares, and remember, 1 is always a perfect square. So now we're going to look at the difference of squares. And 16x squared is 4x plus 1 and 4x minus 1. Okay, now we're going to take a look at our second method, factoring trinomials using sum and product method. So we're looking at ax squared plus bx plus c. Example 1, we have x squared plus 11x plus 24. When factoring these trinomials, the factors will be two binomials. Notice how the x's are the first in the first place of each binomial. We know that the first terms of each binomial must be x because the first term of the trinomial is x squared and x times x equals x squared. The challenge is to find the last term of each binomial. They must be chosen so that they will cause the coefficient of the middle term and the last term of the trinomial to work out. So that's 11 and 24 in this case. Their sum equals the middle term of the trinomial. So something plus something equals 11. Their product of those same numbers equals the last term of the trinomial. So something times something equals 24. We're going to list the factors of 24, okay? We have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Notice that when we sum these numbers together, we get 25, 14, 11, and 10. So you can see that 3 and 8 give you a sum of 11. And it is the factors 3 and 11 that produce a sum of 11 and a product of 24, so they must be the last terms of each binomial. So we have x plus 3 and x plus 8. If we multiply these factors using the FOIL, we get the polynomial we started with. X times x gives us x squared. X times 8 gives us 8x. 3 times x gives us 3x. And 3 times 8 gives us 24. Okay? As we looked at the four terms above, it becomes apparent why the sum of the last terms in each binomial must be equal to the middle term of the trinomial. So that means that our x plus 3 and x plus 8 gives us what we started with of an x squared plus 11x plus 24. Let's take a look at example 2, a squared plus 16a plus 28. What are the factors of 28? They're 1 and 28, 2 and 14, and 4 and 7. Notice that the 2 and 14 sum to 16. So a times a equals a squared, so they are the first terms of each binomial, and the factors 2 and 14 make a sum of 16, so they are the last terms of each binomial. So a plus 2 and a plus 14. Let's take a look at this example here. We have y squared plus 2y plus 1. So what is the factors of 1? Well, they're just 1, right? But they sum up to be 2. Sometimes there's only one pair of factors to consider. So in this case, we have y plus 1 and y plus 1. What happens if we look at this example, where m squared plus 3m plus 1? Well, again, all we do is have the factors of 1, but 1 plus 1 does not equal 3. In this example, the factors available do not make the sum of 3, which means that the trinomial cannot be factored. And that happens, and when that happens, we wind up using the quadratic formula. But we are not reviewing the quadratic formula. Let's take a look at example 5, p squared plus 23p plus 120. What are our factors of 120? There's a lot of them, but which set of these is going to add to 23? In this example, there are many pairs of factors to consider. Most examples will have fewer than these. The trick is to be able to quickly find all the factors of C. Okay? Notice that 8 and 15 equals the sum of 23, and that is our solution. All right, we are going to look at this one. We have x squared plus 5x plus 6. That means we need a sum of 5. Well, that means that this is just x plus 2 and x plus 3. Okay? In each of the preceding examples, the signs of the terms of the trinomials were always positive. Now we will observe examples where signs can be negative. So like this one, x squared plus 5x minus 6. Please notice that yes, we're going to use the same trinomial. We're just going to change the signs. Okay? So we need factors of negative 6. So negative 1 times 6 gives me a negative 6. Negative 2 times 3 gives me a negative 6. So which one of these is going to add to be 5? Well, it would be the first one, the negative 1 plus 6. And that gives you the sum of 5. When looking for factors of a negative number, one must be positive and the other one negative. If at the same time their sum is positive, then the factor that is bigger must be the positive one. Let's take a look at the sign pattern for binomials, okay? So for the trinomial sign pattern, if you have all positives, then for your binomial sign pattern, they too will be all positives. For the trinomial sign pattern, if you have a negative and then a positive, then your binomial signs have to be all negatives because two negatives make a positive. If you have two minuses, then you have one that's going to be a plus and one that's going to be a minus. And if you have a plus and a minus, again, you'll have one plus and one minus, and the next slide will show you why. But as you can tell from the previous example, the FOIL method of factoring requires a lot of trial and error. So let's take a look at reviewing the signs, and this time concentrating on this section in here, okay? That what happens here is the sign of the bigger number determines what is going to be positive and what's going to be negative, okay? So what's going to happen here is you always wind up with the second sign being negative, but your first sign, if it's going to be positive, then your bigger number has to be positive. If it's negative, then your bigger number has to be negative. Okay? And we'll take a look at this example to show that. So we have x squared minus 5x minus 6. And our factors of minus 6 are plus 1 minus 6 plus 2 minus 3. Which one of these gives you a sum of minus 5? Well, it's the plus 1 minus 6. And that gives you a minus 5 when you sum. When both the product and the sum are negative, the factors have opposite sign, but this time the bigger factor will be negative. Now let's take a look at this. If x squared minus 5x plus 6 are factors of 6, notice that they all have to be negative, okay? And the only ones that are going to sum to be negative 5, though, this time is the negative 2 and the negative 3. So you get x minus 2, x minus 3. When looking for factors of a positive number, when the sum is negative, both factors will be negative. Then we'll take a look at this example, x squared minus 5x minus 36. What are our factors of a negative 36? We have 1 in negative 36, 2 in negative 18, 3 in negative 12, 4 negative 9, 6 negative 6. Which one gives us a sum of negative 5? That's right, 4 and 9. Okay, thank you for participating. That's all, folks, and that's our review for some of our factoring methods.